Hello, everyone, and welcome to using OpenTelemetry with Honeycomb. We're going to give people a couple of minutes to join us, so we're not starting just yet. Hang tight and we'll start the webinar promptly in 2 minutes. If you can see and hear me, or you can read the captions, please go ahead and leave a note in the chat box, just 1 or 2 people, so that I know that the audio and visual is coming through on the webinar. Thank you. Once again, we'll be getting started in just 1 minute. Thank you very much for attending this webinar, and we're just giving people a little bit of time to log on, get some coffee, and we'll get started in a minute. All right, let's go ahead and get everything started. It's 9:02 a.m., and I hope that you are excited about today's content. But before we get started, let's cover a couple of housekeeping items that we'll need to keep in mind throughout the presentation. Boop, Philip, we use boop to indicate on next slide. First of all, this webinar is being recorded. After we complete today's content and the recording is processed, if you're registered to attend, you'll receive a link to watch the recording, and you're welcome to forward that onwards to your colleagues. If there's anything that you missed or that you'd like to refer back to, simply click on that link from your email to watch this webinar on demand. Next, we'll be taking questions at the end of today's presented content, but you can ask your questions at any time by entering them into the Q&A box located at the bottom of your screen. We encourage you to ask questions as they come to you, and we should have plenty of time for Q&A at the end. You can also use the chat box to communicate with us and with fellow attendees. Finally, we're joined today by Tracy from Breaking Barriers, who will be providing live captions throughout the webinar. To follow along with the live captions, click the CC or Live Transcript button, and then click View Full Transcript. Or use the link that we just posted in the Zoom chat window, and you'll see that stream in a separate browser tab. So that's it for housekeeping. Let's go ahead and get started and learn how you can use OpenTelemetry with Honeycomb. Today's agenda is 4 items. We're going to talk about how to instrument for observability. We're going to talk about how OpenTelemetry fits in, how you can use OpenTelemetry today, how Honeycomb makes it easier to use OpenTelemetry, and what we're planning to do to improve the integration going forwards. So, boop. My name is Liz Fong-Jones, and I'm a Principal Developer Advocate at Honeycomb, and I also serve as a member of the Vendor Neutral Governance Committee of OpenTelemetry. I'm at Liz the Gray on Twitter, and I'm joined by Philip.
Hi, I'm Philip Carter. I'm a product manager at Honeycomb, focusing on OpenTelemetry and data ingest, all that kind of stuff. And I am at _CarterMP on Twitter.
And Philip, I think you also served as a part of the F# and .NET community before in your previous role. So you're not new to the world of open source.
Indeed.
Cool. All right. Boop. So let's talk about how observability and instrumentation intersect. So it's really important to consider the business purpose of why we're here. What are we trying to accomplish when we add instrumentation to our code? And that perhaps will give us some ideas as to how to most effectively instrument our code and get the results that we want. Boop. So observability has kind of 2 important things that you should be aware of. There are kind of outcomes that you're trying to achieve, and the actions that you take to achieve those outcomes. So when we talk about the outcomes, we're talking about things like improving your code quality so that you write code that works correctly the first time and that passes your tests, and that if your tests are failing, you can understand not just that they're failing, but why are they failing. When you try to release your code, that code should get released in a predictable fashion. It should take maybe 15 minutes, maybe, an hour or two, but not days. And it certainly shouldn't take an order of magnitude longer than it normally does. So kind of visibility into your build process is a key part of the developer experience and how you achieve high quality results. Third, and this is the one that people focus on the most, is kind of operational resilience, right? Once things encounter the reality of how production users are really using them and the broad spectrum of use cases, your code will fail in ways that you didn't anticipate. So how can we debug and understand those issues in production? And then fourth, there's the idea that we should be able to dive in and understand from a BI perspective, what's going on with these features? How are users using them? Are the code changes they made having the desired business impact? And then finally, we need to make sure that we're being proactive rather than reactive over the long term. We need to make sure that we understand where the technical debt is in our system. Where are there single dependencies that are bottlenecks? Where are there circular dependencies? Where are the dark areas of the code that our team doesn't understand? So those are the 5 outcomes that we think are really critical for observability to solve. Now, how do you get there? The answer is that you have to do 3 activities. You have to instrument your code so that it generates telemetry data. And then you have to store that telemetry data in a cost-effective fashion. And then finally, most importantly, you have to be able to query that data. There's a misconception in our space that observability is the 3 kinds of telemetry, right? And it turns out that yes, logs, traces, and metrics are all valid kinds of telemetry data, but they alone do not create observability. Unless you have that end-to-end flow of easy ergonomic instrumentation, cheap data storage, and fast querying to answer your actual questions and not what someone thought you would query in advance, you have a kind of Pokemon, right? Like you've collected all of the pillars, but you don't necessarily have a good understanding of what's going on in your system, even if you've collected all of that data. So that's what we feel observability is about, is the 5 outcomes and the 3 actions. Boop. So how does observability differ from traditional monitoring? The answer is that observability helps us answer questions about our systems that we didn't anticipate in advance. It helps us understand what are the characteristics of these queries that time out at 500 milliseconds, right? I don't have to break down, first by user agent and then by version, right? Like I can find out on the fly what are the common factors and dig into combinations of factors together. So I need to have high quality instrumentation to produce the telemetry data so that I can then analyze it and query it to answer my questions. Boop. So, I talked earlier about this idea of the 3 pillars being a little bit of a myth, right? That metrics are good for kind of aggregate summary statistics, things that you want to measure about the underlying hardware almost, right? Kind of regular processes that are happening on your machines. They're not tied to individual requests. Yes, these are important. These do have some value, but it's a mistake to try to use them to generate data about your application performance and about performance of individual requests. Logs are another common form of signal, but the problem with logs is that they're often very verbose, not structured, and they're they're not coupled to each individual user request. Instead, there's a poor correlation between a log line and which request it came from, or one request is generating many log lines, and it's hard to piece together what happened. So at Honeycomb, we feel that your observability should start from distributed tracing, and then you can augment with other signals as you need. Because distributed tracing gives you visibility into the full life cycle of your application and helps you pinpoint failures and performance issues. And the beauty of the distributed tracing approach is that it fundamentally is generated from trace spans, which are a form of structured data consisting of key value pairs. And if you need to, you can transform that structured data into a metric or a log, but you cannot reverse that process. It's a one-way trap. So how do I actually generate this data? And do I have to lock into Honeycomb in order to use Honeycomb? Boop. The answer is no. OpenTelemetry solves the need and makes it possible for you to connect your data into Honeycomb without having vendor lock-in and using an interoperable standard that is compatible with many providers and allows you to grow and expand how you send your data over time. So let's talk in more detail about what OpenTelemetry is. Boop. So OpenTelemetry is a project that was started several years ago and is something that is a solution to many of the pain points that we are hearing from our customers. Customers are saying that they are tired of having to rip out and re-instrument their code every time that they want to change providers. And additionally, there were kind of confusing standards that there might be your vendor's tracing standard, but also there were two projects that already existed, OpenCensus and OpenTracing. Boop. So OpenTracing was a project that was trying to replace vendor-specific SDKs, but it was also competing with another project, OpenCensus. So when we formed OpenTelemetry, our goal was to support the union of what OpenCensus and OpenTracing supported, as well as try to replace vendor SDKs over time. So OpenTelemetry supports tracing and context propagation and metrics, and we're working on logs and continuous profiling as additional signals that we might add in the future to GA. We also have world-class automatic instrumentation, thanks to the hard work of the OpenTelemetry contributors and thanks to vendors who donated their integrations. It's a project that it has multi-vendor governance, as well as governance from end users. What this means is that people can feel safe using it, knowing that it's not monopolized by one particular party, and that it's always going to try to serve the best interest of end users like you. Boop. So OpenTelemetry contains 4 key areas. It's made up of a cross-language specification that says, how should the language behave? What's the kind of data types? How do you interact with the data types? Is it called start span or begin span? Right, so we've kind of hammered that out so it's clear what has to be implemented in each language so you can move seamlessly between languages and to instrument projects that cross different language barriers and that cross different RPC types. Secondly, there's the OpenTelemetry Collector, which is a Swiss Army knife that really helps you be able to convert between the data types and to be able to collect your telemetry in one place and then tee it off to many different syncs. We also have SDKs and APIs in each language that are designed to interoperate with the idioms of that language. And we've got automatic instrumentation libraries that work with the most common libraries used in each language. So for instance, for Node.js, we support Express. For Java, we support Spring Boot. And for Golang, we support frameworks like Gorilla Mux and more. Boop. So when we talk about the kind of 5 outcomes and the 3 actions of observability, OpenTelemetry helps with the actions. Specifically, it makes it automatic to instrument the most common workflows. It makes it easy for you to extend that instrumentation with your own custom attributes. And then it handles half of the data processing. It helps you route that data to an appropriate destination. It's agnostic about where you send that data to, but it helps standardize how you generate that data. And yes, to answer that question, Boop. So we support a variety of languages, including Java, .NET, Node, Python, Go, and yes, C++. And there are a number of other language SIGs that are in development. For instance, there is a language SIG around Perl and a language SIG around PHP that definitely could use some contributions and help. We're a community project after all. Boop. So now let's go ahead and talk about the nuts and bolts. Philip, would you like to share with people kind of what this looks like in concrete, not just abstract terms?
Yeah, absolutely. Thanks for the wonderful, description of observability and, the outcomes that you want to achieve and how OpenTelemetry can help you with the actions to get there. So as Liz had mentioned, there are some pieces of OpenTelemetry. And so let's go through some of them so that we can cover what they are in a little bit more detail. There we go. So first off is APIs. It's pretty expected, right? OpenTelemetry it's a big API, and you need an API if you want to be able to work with a library. It defines what like traces, metrics, and logs, like what these things are from a code perspective and how you interact with them, right? Ultimately, how you get data out of your application so that you can send it somewhere. And so, as you can see in this code sample here in Go, there's some specific lines of code like OTel.tracer or tracer.start, and you get a span, and then you can set attributes on a span and get data there. Like this is when you're manually instrumenting your code with OpenTelemetry, especially like in Golang, your code is going to look a lot like this. So there's the API side of it, and that's, didn't want to cover too much of that, largely because you're just going to explore that as you're actually using OpenTelemetry. But there's an important concept as well that Liz touched on, which is called context propagation. And so this is what makes distributed tracing happen. It's an abstract data type that is really just a bunch of key value pairs. But critically, this is this object effectively that's serialized across process boundaries. So if you want to hop from service to service, for example, and carry information from that service to the other one so that you can then correlate what happens between the two, this is the object that carries that information. And so you're going to be interacting with your context in different ways, depending on what your specific requirements are. And that may also differ from language to language because there's different idiomatic ways to do it in Golang versus Java or something like that. But the concept remains the same in both, and it's the roughly the same data structure that you're going to be interacting with. And so this is also based off of the W3C trace context standard. And so that's primarily what you're going to be working with. You can look that up if you're interested to learn more. So we have an API, and we have the ability to propagate context across our systems. But one thing that I really love about OTel is the OpenTelemetry side of it, because I'm kind of a lazy programmer, and I don't want to have to do a whole lot of work to get a lot of value out of things. And so that's what auto instrumentation provides for you. I sort of view it in a couple different lenses. I think one of the most important ones to me is that it allows you to bootstrap actually getting data into your system so that you can start with observability without having to do a whole bunch of upfront work. And so, yeah, there's a whole bunch of common frameworks that are already instrumented today. Like I believe the Java SDK has like 50 or so libraries that are automatically instrumented, and like that list is growing and growing every day because a lot of people use a lot of different libraries and frameworks and so forth. And the way that you use it may differ depending on the language that you're in again. So as you can see in this Go code right here, you pull in a package. This is the net HTTP automatic instrumentation, and you basically like initialize it, then you're good to go. And that's going to be common in Go, and I believe Python as well has a similar way to do this. But automatic instrumentation can also be handled via an agent that you can deploy in your own infrastructure if that's what you prefer. And so in that case, it's literally this agent that you install and you deploy, usually as kind of like a sidecar with your application. In this case, this is what the Java agent is typically used for. So you just set a few environment variables, like what your API key is going to be, and like some names for things. This is an example if you want to send stuff to Honeycomb, for example. And then you just run it alongside your application, and what it'll do is it'll sort of like sniff like what libraries you're using, and if there's automatic instrumentation available for that, it'll then automatically instrument that stuff and send it off to the same place that you're going to be sending your manual instrumentation. So I mentioned SDKs a few times, and so I think it's worth talking about the remaining three components: SDKs, exporters, and the collector. So an SDK is pretty straightforward. It's an implementation of the OpenTelemetry API, right? If you're a programmer, you've used an SDK at some point. So that itself is not that big of a deal. However, there are some interesting aspects of this when it comes to distributions of SDKs, because OpenTelemetry is vendor agnostic, but realistically, you're probably going to be using some kind of vendor such as Honeycomb to get good observability. And so there's this question of, okay, well, how do I get that data to Honeycomb? Well, the answer is you need to do some upfront configuration. And so one thing that's really great about this distribution model is vendors like us, we can actually take an SDK, create a Honeycomb distribution of it, where all the APIs are still OpenTelemetry, but we make things like configuring it so that you get data to us as easy as possible, rather than having you have to wire up some boilerplate. We can sort of take care of that for you. Additionally, we in our distributions, we do add a little bit on top of that, like a deterministic head sampler that you can then configure when you run your application, or propagating information via baggage, which is this API concept where you can sort of attach information to a span and then make sure that propagates downward to all child spans that come afterwards. So you can get little goodies in vendor distributions of OpenTelemetry SDKs. So then there's this notion of an exporter. Exporters are, if you don't have a vendor-specific SDK, you may have to actually explicitly wire up one. This is basically using APIs to say, all right, I've collected my data and this is where I'm going to send it, and this is how I'm going to send it. So you can send it to Honeycomb, you can send it to Jaeger. There's a couple options for you, really. And the primary way that you're going to be sending information is via OTLP, or OpenTelemetry Protocol. This is a protocol that Honeycomb actually natively understands, so you don't have to like transform the data in another way or that kind of stuff. And you can send OTLP over a couple different mediums, like you can send it over gRPC or HTTP with protobuf. There's a forthcoming HTTP with JSON as the backing wire format. So that's just what an exporter is, pretty straightforward. And then the last one is the OpenTelemetry Collector. And this is a proxy that sits in between, like your service and where your data is going to be going. But the collector is interesting. It's not just some proxy that you throw up on your infrastructure somehow. The collector is the Swiss Army knife, as Liz mentioned. It's really, really useful for a number of different use cases. So for example, if you already have a distributed system that's been instrumented with something else, like Open Tracing or with Jaeger tracing, or maybe you have Prometheus metrics that you've already been collecting, and you want to be able to collect all that information and then send it off to a backend somehow. How do you do that? Well, usually the answer is going to be the OpenTelemetry Collector. Now, of course, like you could rewrite everything, but like that's not tenable. And so that's where the collector comes in. You can configure what are called receivers that will receive information from different kinds of data sources, and then it will transform that into OTLP and then send it off to wherever you want to send it off to. But it's not just for receiving inputs from different formats. You can also transform the data as it runs through the collector. So you may have spans of a particular kind, and you want to filter some out based off of a rule. Or maybe you want to process the data that are in those spans in a particular way. It's customizable so that you can write those sorts of things. And you can even create your own distribution of a collector if you're doing something that is like, very specific to the use cases that you have, and you want to make sure that that's guaranteed to be, deployed across your infrastructure, and it's the same kind of collector that everybody's using, and so on and so forth. It's very customizable. It's a very great tool to have, especially if you have some of these more advanced use cases like multiple input data types, or a need to process the data in some kind as it runs through. So it's available pretty much wherever you would want it to be. There's builds available in different CPU architectures. You can deploy it pretty much anywhere. And so, yeah, it's a very important piece of OpenTelemetry that I recommend looking into as well. So covered some of the nuts and bolts of OTel. But let's get into like how you get that data into Honeycomb specifically, because so far we haven't talked about any of that. All we've just talked about is vendor agnostic stuff, which is great. We love that, but there's a little bit extra from the Honeycomb side that I think is pretty great. So really our goal here with OpenTelemetry and how that relates to Honeycomb is we want to make it as easy as we can. Because the reality is that when you're working with something that's vendor agnostic, like you get a lot of benefits out of that. But usually when things are vendor agnostic, it's like there's a little bit more work that you have to put in to get the true value out of that. And we think we can sort of shift that to be a little bit easier with some of the things that we're doing. So if you want to get started with instrumenting with OpenTelemetry and getting data into Honeycomb, there's kind of this 4-step process that I think is really helpful to go through. So the first is you want to pick an appropriate entity to get your data in. So that could be a Honeycomb SDK distro of a particular language. If you decide not to use that, you could use the vendor neutral OpenTelemetry SDK, and then you just wire up an exporter that points to Honeycomb. And you may have reasons for that. Or you can pick the OTel collector. You know, whatever works best for your requirements and what you're trying to do, you pick the correct one. Then you configure it with your API key, and you specify like your data set in this case, and you say, okay, I want to send data to this spot. See if you can wire up automatic instrumentation first, because that's the easiest way to get a bunch of data in where you can already start gleaning some insights, and then manually instrument your code over time. So, I mean, you could start with manual instrumenting your code as well, but I think it's usually easier to start with auto instrumentation and then get a little bit of manual instrumentation in there, see what you get out of that, iterate and continue forward like that. And that step 4, that can happen over time. And realistically, it is going to happen as your systems evolve and you want to continue to instrument. You're going to be revisiting that quite often.
The analogy I like to use there is kind of like, you know, automatic instrumentation is the skeleton, and then like any manual instrumentation is kind of like the connective tissue, the muscles, right? Like it kind of all works together, but if you don't start with the right skeleton, you're going to wind up with, you know, a pile of goop. So you kind of have to make sure that everything is structured correctly and go from there. The other important thing about that first point is that even if you start with the Honeycomb SDK distribution, all of the instrumentation that you're writing is going to be against the vendor neutral API. So if you do choose to wind up going to another provider down the road, you can do that. You don't have to re-instrument your code. You can just swap back in the vendor neutral OpenTelemetry SDK.
Yeah, that's absolutely correct. So, you know, that 0.3 and that 0.4 and really all of 0.1, like that's, none of that has, like, there's a little bit of Honeycomb in there, like where you put your API key and the entity that you're gonna send data to, and that's it. From there, it's just OpenTelemetry. And we think that's great because, you know, you should have the freedom to pick a different backend if it works better for you. Like you shouldn't be tied to a vendor just because you wanted to get some insights at one point in time. So I like to approach this from a couple of different angles. So the first one is if you're not instrumented today, right? If you're just starting off, highly recommend starting with a Honeycomb SDK distribution. It's super easy. You just install the SDK. You know, like if you're using Java or .NET, you just use one of the package managers, or you can even download stuff from GitHub. It's totally fine. Each of these SDKs has very quick idiomatic configuration. So configuring stuff to point to Honeycomb in Java is going to be different than configuring stuff to point to Honeycomb in .NET, and that's fine because there's different configuration mechanisms in each of those languages. And so we make sure that our SDKs do that as friendly as possible, so that configuration code is going to look the same from other libraries that you've used before. Each of them has automatic instrumentation that will automatically light up once you just install it. There's nothing else that you have to do really. And then we just expose the OpenTelemetry API from there. And when you manually instrument your code with OpenTelemetry APIs, you're pulling in like OpenTelemetry namespaces and using like the trace data structure, for example, like there's nothing special about that. There's no Honeycomb attached to it or anything like that. It's all just OTel. And so today we have Java and .NET already supported. You can go and use that right now for our SDK distros. And Python, JavaScript, Ruby, and Go, and more likely are coming soon. This is, you know, an ongoing thing where I imagine if you talk to me next month, there's probably going to be like a third language icon up there. It's pretty fast moving, and so that's great. And another thing I want to call out with the Java and .NET side is we've already have quite a few people instrumenting their code with this, and so we're going to be moving towards general availability of our SDK distros and those over the coming months as well. So this isn't like some super bleeding edge thing that we're asking you to hop onto. Like this is very real. We have customers already using this today, and we recommend that you jump on this if it applies to you.
The other important thing to highlight here is that OpenTelemetry, both the vendor neutral variant as well as the Honeycomb distribution, both of those are production battle tested. They are going to be stable in terms of your impact on your code. It's really about the kind of stability of the APIs and potentially having to change your API calls to the OpenTelemetry SDK. Those have been the thing that have seen flux over the past year and have settled down now. But it's not like this is something that has never been run in production at scale before, right? Like this is something that we use at scale every day.
Yeah, exactly. And really sort of our primary like decision process around like, hey, what's the next one to pick? Or what does GA mean? Like the questions like that is very heavily influenced by upstream stability, because we don't want to push something on a bunch of people and then have all their APIs change all of a sudden. And so, but that time is now. Like things have stabilized considerably. And so that means it's a great time to get started with this. So let's say you're also not instrumented, but there is no Honeycomb SDK distro for your language, right? Like if that were the case today, like for example, we don't have one for Python today. How would you do that? Well, it's also pretty easy actually. You have to, in this case, you would install the vendor neutral SDK instead of our distribution of it. And then configuration is a little bit more work. You have to configure which exporter you want and how it's going to point to Honeycomb. But then after that, you're good. You can set up automatic instrumentation, and that might be a little bit more work than if you had one of our SDK distros, because we try to make that as automatic as possible. Whereas, like for example, in Python, you have to make a decision on if you want to pull in specific auto instrumentation packages, or if you want to deploy a auto instrumentation agent. But then once you're there, it's the same story. You manually instrument over time. And so getting, for example, Python to point to Honeycomb is also pretty easy, right? There's just really sort of like these 4 sections that I laid out in this code here. Like you specify, hey, I have a service. Well, what's the name of this service? And in this case, it's an environment variable, but you can specify that however you want. It's just a string. You want to set up a tracer provider. You want to set up critically this thing called the OTLP span exporter. And so this is the data structure that basically contains all the info that is like, all right, this is how I'm going to actually send data there. And so you got to specify an endpoint, in this case, Honeycomb API endpoint. And then you want to attach some headers to it. The headers bit is the important bit. And that header is going to have your API key and the data set that you're actually sending data into. And so how you pass that information into the span exporter is up to you. This code sample uses environment variables, but it could be anything that you feel works. And then you add that exporter to this thing called batch span processor. You then attach that to the trace provider, and then you're good to go. So like it's a bit more work, right? Like if there were an SDK distro for this, like you wouldn't have to write this code. You would just plug in an API key in a data set somewhere and you'd be good to go. But it's not that bad. And this means that you can start with OpenTelemetry SDKs that are vendor neutral today and get a lot of value out of it. And then once we have a distribution of an SDK, basically that would just mean you get to delete some code if you choose to use it, which is great because everybody loves deleting code. So another way that you might get started is what I mentioned before. So you may already be instrumented using another telemetry framework. And we don't want you to have to go and delete all of that instrumentation that you've done just to be able to get data into Honeycomb. And so this is where the OpenTelemetry Collector is going to come into play. So you're going to have to configure an appropriate receiver. I don't have a code sample for that, but there's a link down below, and we have some examples of how to do that. And the OpenTelemetry documentation also describes how to do it. Whatever you're using to instrument, you set up a receiver to collect information like that. Then you configure what you want your OTLP protocol, what you want it to be sent over. I think gRPC is the default. Yeah. And then you set it up to point to Honeycomb, and then you should probably set up a plan to migrate your instrumentation to OpenTelemetry over time, but this lets you get value out of the system today without having to do that as a prerequisite.
And you don't have to rework your trace header propagation as well, because OpenTelemetry supports both the B3M standard that people may have used before, and it also supports W3C. So you can kind of mix and match as you go until you get everything converted to W3C.
Yeah, that's absolutely correct. And so You can view our documentation or the OpenTelemetry documentation for how to do this. Our documentation is going to tell you how to set up the endpoint and the specific things that you need to set to send data to Honeycomb. But it's very little configuration code from here. Once you've figured out how you're going to collect your information and do what you want to do with it, and you say, okay, I want to send it off. Now it's just the endpoint, API key, data set. And then you're good to go. Once you deploy this, it will automatically send that data over to Honeycomb, and then you should be good to go. So if you're already using OpenTelemetry, it's super easy, right? You just need to modify whatever exporter you already have in code. And then you may want to consider using a Honeycomb SDK distribution in the future. But if you're already getting a bunch of value with this right now, then that's totally great. Whatever config you're using, in this case, I have JavaScript right here. I've bolded some of the things that you may want to change. And it's just, again, it's the endpoint, API key, and data set. And then in this case, also the service name, that's right. So there's kind of a common theme here where there's not a whole lot that you need. You just need to say, what's the endpoint I'm setting data to? What's just the small bit of metadata that I need to get value out of Honeycomb? And that's it. And so we make that easiest if you have a Honeycomb SDK distribution. And if you don't, then it's a little more work, but it's also not that bad. It's, in this case, like 10, 20 lines of code. So yeah, there's a lot of different ways to get data into Honeycomb. All are, I think, really easy to get started with. It's just a matter of where you're coming from. And yeah, so I think now there's this question of what's next for us, right? And I think the answer is we're not this is a good status quo, right? You have lots of different options. Config isn't that bad, depending on your options. It's obviously easiest if you have an SDK, and you can send that data to Honeycomb and you're good to go. But we want it to be a little bit better, and it's just more Honeycomb and OTel. So number one is we're committed to building more SDK distributions. So pretty much if there's a major language that has an upstream SDK that is stable and that you can use, it's pretty reasonable to expect that over time Honeycomb will have a distribution for that, right? Again, we have it for Java and .NET, but for JavaScript, Python, and Go, you could expect those to come. Same thing with Ruby. There's pretty much anything is on the table at this point. Things like, I believe there's Swift and Rust and C++, and there's some activity around PHP. I don't want to commit to one specific one at a given time because it's going to depend on a variety of factors. But at the end of the day, we want to create more of these SDK distros so that you have less config to send data compared to the current status quo if you're not already using Java and .NET. The next piece in terms of what's coming next is more spec support for accepting data that comes in. So today you can send us OTLP over gRPC, and you can send us OTLP over HTTP with protobuf, and you can send us traces and metrics coming over those. But there are a few more things like OpenTelemetry logs. The specification right now, I believe, is still experimental. As that stabilizes, you should expect to be able to send us OpenTelemetry logs as well. There's also another format, which is OTLP over HTTP with JSON as the serialization format. And that, again, is also experimental, but once that leaves experimentation, again, you can expect that we will also support that. So you could conceivably send us traces over gRPC, metrics over HTTP protobuf, and logs over HTTP JSON. And I don't see why you would do that, but you should be able to do it because orthogonality matters. And we're committed to making sure that that can happen. But realistically, what that means is that some languages it may be more idiomatic to send over, say, HTTP JSON than gRPC, and you shouldn't have to step outside of the comfort zone of what you're used to be able to send us data. So that I would say watch for the status of these things that are experimental today, and that'll give you a pretty good indicator of when those are going to light up in Honeycomb. So, and we're watching these as well. And then the last is it's about upstream contributions. So we're already doing this today. We're starting to contribute to the OpenTelemetry Collector, and we are doing plenty of upstream SDK improvements today already. I believe one of our engineers is a maintainer of at least one of the SDKs. We want to do more of that. because eventually, like once we have these distributions of the SDKs, it's great. Then it's just all about improving the upstream as much as we possibly can, so we can get as much goodness for everyone, but pull that stuff down into Honeycomb, right? We don't want to build a whole bunch of good stuff that you can only get via Honeycomb. We think that if something is specific to Honeycomb, it stays in our distro, but if it's just a generally useful thing, it should be in the upstream and everybody should be able to use it regardless of their environment.
And some of those things that we're talking about are things that were previously in our proprietary instrumentation in the B-lines, where people who are seeking a migration path from B-lines to OTel are like, hey, wait, this feature is missing from OTel, right? Great, let's give it to you in a Honeycomb distro, and then let's work to upstream it if it's generally useful.
Yes, that's absolutely right. And a big part of that is going to be improving upstream automatic instrumentation. So some of what makes the Honeycomb B-lines today great is that they have really fantastic automatic instrumentation for certain libraries. And in some cases, that automatic instrumentation already exists in an upstream SDK. In some cases, it doesn't. In some cases it does, but it's not as good as it could be. And we want to make sure that it is as good as it could be, right? Anything that you have in a B-line and beyond that really should exist in an upstream SDK, and it should be world-class. And so we're looking to make contributions along those lines in the future as well. So more SDKs, more spec support, such that if you can do something with OpenTelemetry, you can send it to us, and making automatic instrumentation as awesome as possible. And that is really, I think the big picture is we're all in on OpenTelemetry on this side. Like, we think this is the future of how you instrument your code. And, it's exciting, but also I believe one of our engineers describes it as instrumentation should be boring. And it really kind of should be in a way, right? Like, it's exciting in the sense that like you can get data from all the things that you care about, but at the end of the day, it shouldn't really be that big of a deal, right? You should just be able to do a little bit of configuration, manual instrument over time, and not really have to worry. You just send your data to Honeycomb and boom, everything just works. And so that's where we're headed.
So what's the TLDR?
Yeah, that's the TLDR, I guess. Yeah, I think we're ready to take some questions.
All right, let's start with a relatively simple one. Vitor asks, if Spring Boot microservice A is using automatic instrumentation and communicates with another automatically instrumented microservice B, do the spans continue? The answer is yes. So if you use the Java OTel agent, it will automatically both hook into the receiving side of Spring as well as the sending side of Spring. So it will look at any trace headers that are coming in and will propagate trace headers going out. And it will also instrument the code running inside of Spring Boot. So you'll get continuous traces from point A to point B. It's really great. All right. Next question is from Ilmo, who asks, what about secure tenancy with OpenTelemetry? Philip, that's a great one for you, because I think your team worked on this recently.
Yeah, so there's a couple pieces to that. So number one, if you're sending data through secure tenancy to us, like there's nothing, like it still works, which is the thing that we care about, right? Like, important information gets masked via the secure tenancy proxy exactly as you would expect it.
It gets sent from the OTel collector to the secure tenancy proxy, which then sends it on to Honeycomb. So the secure tenancy proxy understands the OTLP protocol.
Yeah,
and for people who don't know what secure tenancy is, we should probably review that. Secure tenancy is Honeycomb's technology for masking data so that you can keep custody of the encryption keys, and therefore it meets regulatory and privacy requirements.
Yeah, that's exactly right. And so the OTel spec support on secure tenancy is currently a little bit behind our endpoint support, and that's because customers there expect it to be rock solid. And we want to work out any kind of kinks before we get everything fully into secure tenancy. So right now it supports OTLP over gRPC, and OTLP over HTTP is coming soon. And I would expect then that, as the OTLP over HTTP with JSON comes in, like that will also make its way into secure tenancy. So one of our goals there is that if it works without secure tenancy, it should work with secure tenancy, and that's really basically it.
Yeah, some of the fun stuff we've been talking about is how does secure tenancy interact with resource objects? Should resources be masked or not, right? Like, those are some of the things that we're working through. Questioning from Anthony is, what's the timeline on the SDK for other languages, specifically Go? I'm eager to hear this one too, because Honeycomb is a Go shop, and right now we actually don't have a Honeycomb distro for OpenTelemetry Go. So I can answer the Go SDK vendor neutral question, which is it's GA. It's been GA for now 2 weeks. I've adopted it in our demo projects. It works flawlessly. But with regards to the Honeycomb distro question, Philip.
Yeah, that is a good question. We're still in the decision-making process, I guess you could say. And so to give a little bit of insight into that, about a month ago, we were being like, okay, well, what's the next SDK distro that we're gonna work on? And at the time, Go was still RC, and I believe Ruby and JavaScript were also release candidates, whereas Python was already GA. And so we tentatively said, okay, we'll go with Python next. But now that everything is GA again, we're like, oh boy, okay, now we get to pick from, I believe, like 4 choices, and all of them are good. I think we might still be leaning a little bit Python, but it's, I think, probably TBD. But I guess the big
This is all work that we know we want to do in the next 6 months, which just which order it happens in. So
yeah, exactly. Within like the next 6 months, that this should not be a question at all. It's just a question of within the 6 months, what's the ordering of like each month, like that. That's sort of.
But like, by all means, start using vendor neutral OpenTelemetry Go. Like, it's just a couple of lines to add the config. Really, what the OpenTelemetry distros are is us making it easy for new Honeycomb customers to adopt OTel if they're not already using OTel. If you're here, you're excited about OTel, go for it. We support completely vendor neutral OTel out of the box. Just send us OTLP, and you don't have to switch to a distro unless you want that additional kind of support and stability guarantee from us. But also, we're active in the community. I once was a OpenTelemetry Go approver. I stepped back from that, but we still stand behind it. We'll support you. We'll work through it with you. Yeah. And that actually brings us to our next question. Go ahead.
Oh, sorry. I was just going to say, we already have a lot of customers today using an Upstream SDK sending us data. So you can just be another one of those people.
Yeah. And that brings us nicely to Mark's question, which is, if there's already OTel, why bother using the vendor-specific SDK from Honeycomb? Isn't a neutral SDK a better solution in the long term if you decide to move away from Honeycomb? So that's a great question. And I think basically the answer is the APIs are always vendor neutral, and the SDK is hot pluggable under the hood. And in reality, the only thing we've really done to the SDK is to add additional integrations that are baked in from the start. You could, take our distro and configure it to write OTLP to another destination, right? We've done nothing to lock out additional destinations. All I've done is enhance with a little bit of extra magic and functionality, and that's completely open source. You could fork it as well and put it into your copy.
Yep. Yeah, I think that makes total sense. And like there's other pieces of OTel where like some things are considered like must-haves versus optional. And that's where, any particular vendor may say, hey, well, we're going to promote something that is a part of the OTel spec, but isn't a requirement that every single SDK has, a feature for. And so, more broadly speaking, if you use a vendor-specific SDK, like that might be the additional stuff that you get there. But it's all just pure OTel, and it's just a matter of how much you want to configure upfront. And we try to make that configuration as little as possible. So.
Yeah, the thing I've discovered from running at this point years of OpenTelemetry workshops is it's kind of boring, like putting those 10 to 15 lines of boilerplate inside of every new OTel app that you create. People shouldn't have to worry about that detail unless they really want to get down into the nitty-gritty. And our goal is to make it as easy as possible, but OTel at the end of the day has to be opinionated about some things and require setup and glue because it's aiming to support a wide variety of things, whereas we can give you the sensible defaults that work best with Honeycomb out of the box without you having to type additional words. Okay, let's see. There's a question from Kamal who says, Honeycomb doesn't support non-scalar attribute values. Is there a plan to implement that? So with regard to non-scalar values, we do support JSON and furling at our endpoints. So if you have things that are packed in JSON format into an attribute, we will unfurl it on our side. However, the OTel spec side of if you're using the native OTel array and object syntax, that's something that I think is, we value feedback. Philip, I don't know where that falls on your list.
Yeah, I don't, it's certainly not on the high priority side of it, but you can definitely, that's something we'll take into account. So.
Yeah, definitely. If you needed to do something in the short term, OTel collector module, npack the nested attribute or the list, pack it into JSON, and then send it along as a flat JSON string, and we'll unpack it on our side. So that's a workaround I can suggest for now. It should be pretty easy to do, but we haven't had anyone need to do it so far, so that's why I don't have open source code to show you there. Anthony asks, will Beeline continue to be supported, or will OTel be replacing it? Philip.
Yes, so beelines are continue to be supported, pretty much indefinitely at this point. What I'll say is, like, new feature development on them has pretty much stopped. Like, they're stable, they work, they do a great job for what they are, and we want to keep that going. Additionally, you can interoperate with beelines and OTel. So if you instrument with OTel in one service and a beeline in the other, like, you don't have to get rid of your beeline code. Like, you just set W3C trace header propagation and your configuration for the beeline to true, I believe, and then it'll all work. But yeah, we're not going to be adding new features to the beelines right now. And you should feel like you can still continue to use them. But if you're going to be instrumenting a new service, we definitely recommend starting with OTel. And if for some reason you have problems with that and a beeline would work, go ahead and continue to use the beeline, and there's no problem with that. Eventually,
you want to hear about features that are missing from OTel, though. So if you see something that is stopping you from moving from beeline to OTel, you decide you want to standardize and consolidate, we're here to support you in it.
Yes,
we're not going to make you move.
And eventually, once we have, so there's more Beeline SDKs than there are Honeycomb SDK distributions of OTel SDKs. Once we have like parity in terms of the number of languages, you can also expect that we're going to write like a migration guide to help you move from one to the other that you shouldn't feel like you have to do. But if you want to migrate, we can give you a lot of recommendations on how to actually do that. But that's not happening now.
That'll be shims, but we're not there yet. We're not there yet.
Yeah, that'll be a while from now. So.
Cool. Richard asks, in the 1990s, we had application response measurement and kind of APM, ARM, which kind of never took off. Why is OpenTelemetry seeing widespread adoption? So I think the answer to that is previously, throughout the 2000s, there was this problem where tracing was viewed as not worth the squeeze, right? That it was a lot of work to set up and that the results you could get out of it were very limited. It was hard to find the right trace. It was hard to process that volume of data. And there wasn't necessarily the same challenges we have today with distributed microservices, right? You could suffice just fine with logs out of your one monolithic service. That doesn't work anymore. So it's that the problems have gotten harder, resulting in people needing to find new techniques or older techniques to solve them. And also that it's gotten easier to instrument, right, because of this consolidation upon a vendor-neutral standard. It's gotten easier to process the data because there are a number of vendors, including Honeycomb, that do it for you, right? So it's no longer, I had to do all this work to set up open tracing, and then I had to set up Jaeger, and like, you don't have to do that anymore, right? So I think that and the better value proposition is why OpenTelemetry is now the second most popular cloud-native computing foundation project after Kubernetes. All right. So Anthony asks, is there an effort to hook into infrastructure as code languages like Terraform? This is a fascinating one. So the answer is yes. There is OTel CLI, which is a Swiss Army knife for the command line. That is intended to encompass the wide variety of things where you might, be issuing AWS calls, or you might be doing something in a shell script, right? That can then be hooked into an OpenTelemetry span. In the longer term, we'd probably like to take that and just, build using the OpenTelemetry Go SDK directly into the Terraform code, which is Golang. Right. I think in the future, we shouldn't need to have auto instrumentation libraries, right? The library should be instrumented with OTel out of the box. And I see that Kubernetes and Terraform and other upstreams are going to start integrating the OTel APIs now that they're 1.0. So I think that's the longer term path. I don't think it's a Honeycomb specific effort. But I do think that it's the direction that we're headed as an industry, and I think OTel can help by providing a stable API that is vendor neutral, that is the standard that people can depend upon. Let's see. Richard asks, do you see capacity planning or capacity management groups leveraging observability data? Hey, Philip, I think you just published a blog post about this.
Yeah. So Yeah, so what I would say is that there's a definite yes. I mean, it's clearly going to depend on the use case. One example here is if you are, this is what I blogged about, for example, one of our customers, Blackbot, is doing, which is incredible. So they sort of automate promotion of Canary deployments to the entire world, depending on certain criteria. And I sort of view it as like the ultimate system integration test. Where like you basically establish some bounds of behavior. You're like, okay, well, like response time should fall within a certain threshold or that kind of stuff. But instead of having like this wild infrastructure that like simulates user behavior or something like that, it's actually just users. And then critically, if you're well instrumented and you have a tool like Honeycomb that allows you to get that kind of detailed information as fast as possible, you can then use our APIs to extract information about what's happening in those deployments, and then run that in a system that will then say, okay, well, traffic, a certain amount of traffic has fallen within this criteria. We think that's good. We're just going to promote it. And you don't have to like deal with that anymore. You set up the infrastructure and now it's automatic. And then whenever there's something that does fall outside of that range, then you can use Honeycomb to data.
Yeah, it's pretty great, right? Like the data API lets you do anything from feature promotion to capacity planning and capacity management, as Richard is asking about, right? Like it's kind of this tool for using the same tool that your production engineers use to also drive your automation, regardless of what kind of automation it is. Great. And our final question is from Deepak, who asks, is there any work ongoing for logs GA and specifically what to log and how much? So Honeycomb right now is not our highest priority to work on upstream logs. If you do have a pressing need right now to integrate your logs with Honeycomb using OTel, our recommendation is span events. Span events are key value pairs, similar to structured logs, which you can attach to an existing trace span. And we will ingest those into Honeycomb and present them as child events that are displayed as a marker on that timeline, that are displayed as like a point in time in the parent trace. So that's how you can couple logging type data that has a timestamp and attributes, but not necessarily a duration, to your existing trace data in Honeycomb. Broader log support, we're going to have to wait and see, but I think that is the thing that you can do now if you want to integrate that data type. Cool. Oh, and there's also a question. Deepak also asks, can you generate traces from the browser and get RUM in OpenTelemetry? The answer is yes. OpenTelemetry.io actually is instrumented with a browser trace. So you can go pop open the source code for OpenTelemetry.io and have a look. And you will see the request flowing outbound to an OTel collector, and from there to, I think, Lightstep and Honeycomb and a number of other OpenTelemetry backends, so that you can kind of, we're working on making that data set public, so you can hit OpenTelemetry.io and then go look and see your own browser requests and the JavaScript page loads happening. So it's really cool stuff. But there are a number of considerations about kind of leakage of API keys and things where we really recommend using an OTel collector. We don't recommend sending directly from the browser. That's an almost entirely separate webinar. I think we will do at some point in the future something about kind of how we use instrumentation in the browser. All right, so that's all we have time for today. And thank you very much to Philip for joining me for today's presentation. And remember that a link to watch this webinar on demand will be in your inbox soon. Please feel free to share this webinar using that link with your colleagues if you like today's content. You can also find more webinars and other helpful content at honeycomb.io in our resource library. And you can follow Philip on Twitter @_CarterMP or myself @LizTheGray. Thank you for joining us. Happy week, everyone, and happy instrumenting.
Thank you.